Good morning. Just finally got back yesterday. I was gone all week for a conference. So now that I'm back at work, I'm going to do another video today. This one will be calculus related, and we're going to look at the area between two curves. All right, so if I have two separate graphs sitting here and I'm starting at point A and stopping at B, right? I start at A and stop at B. The area that's closed by both graphs is what we're trying to find the area for. Now, we have a way that we can do that using the integral, also known the definite integral, to figure out exactly what that area could be. All right, so the way that I like to think about it is like if I were to draw what I call, this is going to be like a representative. This is like a slice. Sometimes you might hear me call it like a slider. That right there, that's going to help me figure out exactly how I'm going to find that area as it starts here and drags its way across. Now, the main thing is, since this is vertical, you want to think of it as a top minus a bottom. All right, because that's how you figure out how long this is, by using top minus bottom. If it was sideways, it'll be right minus left. So I always kind of draw that so I can see it, so I understand, okay, how I'm going to set this up when it's time to. Top minus bottom, when vertical, all right? So verbally, if I integrate, this is going to help me find the area starting at A and stopping at B, right? From A to B. What we're going to have to do is a top minus a bottom with respect to whichever axis we're going across. So in this case, we're talking about the x-axis. So we have to do a top minus a bottom dx. And what that will give me is the area, all right? Top minus bottom with respect to x for this example, all right? All right, so here's my two functions that I have. I have f is equal to x squared minus 6, and then g of x is equal to not square root, the absolute value of x. Notice I have two different colors, blue and green, so that you understand the absolute value is the blue, the parabola is the green. So that's how my graph actually looks. It looks just like this, and this is the area that I'm trying to find, this weird little part right in the middle. All right, so before I can set up the problem, I do need to know where they intersect. And so the intersection I'm going to focus on is the one right here. And see how I have a point A, that's the intersection. And it happens when x is equal to 3, all right? That's very important. I'm going to actually show the steps on the board, but that's going to be an important part of what we do to solve the problem. All right, so the way that we find this by using some algebra techniques is, these are my two graphs, x squared minus 6 and x. If I set them equal to each other, that's how I find the intersection. So this one comes over here as a negative x, all right? Positive x on this side of the equal sign, negative x on this side of the equal sign. And through factoring, once again, this is all algebra stuff right now. I have a x plus 2 and an x minus 3 is equal to 0. And this is the part that I just found right there. X is equal to 3. Now, when I set up my integral, and let me just kind of get this out the way real quick. Let me erase all of this. I don't want anyone to see that yet. When I set up my integral, I have to do a top minus bottom. The absolute value part is the top part, and the x squared minus 6 is the bottom part. So I have a top minus a bottom. And I'm going from 0 to 3. All right, from 0 to 3. I'm about to explain. So remember, I have to do a top part minus a bottom part. So the blue is on the top, the green is on the bottom. And remember, I'm not going to go from this end all the way to this end, not when I do it on paper, because it'll be easier to just start at 0 and stop at 3. And since these two are symmetrical, once I understand this half of it, I just do it times 2, all right? So when it's time to set up the problem, I'm going to set it up from 0 to 3, but I'm just going to double my answer. So that's why I have my top minus bottom, right, with respect to the x-axis, and I'm going from 0 to 3. And remember, I'm just going to put that little 2 right there. That's letting me know that whatever this answer is, I double it, all right? I'm going to double whatever happens here. So now these are the steps that I'm about to show. And depending on who you are, this stuff might be kind of like redundant. You probably already understand this process, but I just want to show since I'm doing everything by hand right now, I just don't want to skip certain steps. So distribute that negative sign. Now I have a negative x squared. I have a positive 6. And every last one of these, I'm going to get the antiderivative for. So if I integrate x, I get an x squared over 2. If I integrate x squared, I get an x to the third over 3. And if I integrate 6, I get 6x. And remember, we're going from 0 to 3. And I'm going to double that. All right. 0 to 3, and I'm going to double that. So the good thing about this is no need to plug in a 0 across all 3 of these because your answer will be 0. So all I really need to do is plug in the 3, substitute my 3 in everywhere you see an x, and then whatever my answer is, double it, and it's over. I plug in the 3 here, I'm going to have a 9 over 2. Plug in the 3 here, I'm going to have a 27 over 3, which is 9. Substitute my 3 here, I have an 18. So let's see what this answer is going to say. If I double this one, I'm going to get a 9 minus 18, right? Everything gets doubled, and then that's a plus of 36. So here we go. 9 minus 18 is a negative 9 plus a 36. The answer is 27. The answer is 27. All right, so I like verifying using my computer or graphing calculator or anything like that. So remember how I started from 0 to 3 and then I found the integral and I said, okay, I can find that answer and double it. This is literally what it would look like if I found half of it. Half of it is 13.5. And guess what happened when I add another 13.5? You get 27. So that right there is one way I can look at it. I can look at half of it, or I can just tell the computer to do the whole thing from start to finish, and it's going to crank out. And this would be what it would look like if I were to do the whole thing across, and then there's the 27. So the area that was covered, or the area that's in between these two curves, is 27. And all this is found by using an integral. An integral between two curves, remember, you integrate from start to finish, whatever that could be, from A to B. You do a top minus a bottom, and then it's going to crank out your area for that specific location. Okay, so I'm going to probably do more of these types of problems this week. Today, we did an absolute value, a top minus a bottom. Tomorrow, we might have to look at a right minus a left. This happens if the things are horizontal now. So vertical or horizontal, the idea is the same. You want to do your top minus bottom or your right minus left. So I'll see you all on tomorrow. I'm going to do some more examples about those this week. I decided to document a couple of days worth, a few minutes here and there. So you can check those out and see what happens at math conferences. And the rest of them are just video lessons.